What are the assumptions? They are the core. All right, remember I said the core is going to apply to every single t-test and ANOVA. But there is another one. So for this test, the independent t-test, the assumptions are the core plus one more, and that one more is homogeneity of variance, or HOV for short. And you learned that in the lab. We're going to cover it in detail now, but you already learned something about it. So, what does HOV state? It states that the variance for group 1 is going to be statistically equal to the variance for group 2. All right, so if we were to calculate variance for group 1, variance for group 2, and run Levene's test on those two variances should be equal, which means that Levene's test will be not significant. All right, so this is a case where we do not want any test of assumptions to be significant. Remember the mnemonic? We do not want our ASs, short for assumptions, to be significant. Ever. So HOV is tested using Levene's test. It's also called the F-max test. And it just depends like which textbook you pick up or whatever, but just know that the F-max test and Levene's test is basically, it's the same test. In the Levene's test, we calculate an F value. And if that F value, it turns out to be not significant, so we're going to look at the sig value for this F. And if the sig value says that the test is not significant, does this mean that the variances are different because of sampling error or a treatment effect? Not significant means we are retaining HO, null, none, and nothing. It means that our variances are probably different just because of sampling error. Now, is this a good thing or a bad thing? Well, if this were a t-test or ANOVA, we would be saying, oh, it's bad, we didn't get significant results. But remember that this is a test, Levene's test is a test of assumptions. And we never want those to be significant. So this is a good thing. It means that our variances are probably equal, statistically anyways, right? So we're happy. And again, can't stress this enough, remember the mnemonic. We never want our S's to be significant. If they are significant, that means we have a violation. The assumption does not hold true. There's been a violation, all right? And that is a problem. Well, it can be a problem. So let's look at what happens if we have a violation. Well, with this independent t-test, SPSS is actually really nice because it gives us two sets of results. One where the assumption is assumed to be true. So one where we assume equal variance. And right below it, do you remember? Right below that is a row of data where we assume that the assumptions are not the same. And so the SPSS gives us a modified version of the independent t-test. And we look at this modified version if we have a violation to Levene's test, okay? Not Levene's test, but if Levene's test says that we have a violation to HOV, then we look at this modified version. Now, another option is to run the non-parametric equivalent test. I usually don't bother. I look at the modified version of the independent t-test that SPSS gives me. And if it's significant, then I just report that. And, I really don't pay attention to this, because if it's not significant with the modified version, then it's not going to be significant here. This is not very powerful. The modified version is a little bit more powerful. So again, if your results are not significant using the modified version, then there's no point going to this non-parametric equivalent. For sure, it's not going to be significant here. Right? Both of these options lower the probability of finding significant effects. All right, this one even more so, this one a little bit, this one more so. So they both lower the probability of finding a significant effect in your t-test. What if you ignore the violation? Remember, you can do that. You can say, oh, t-tests are robust. We're going to ignore the violation. Well, there's one good thing about this. Ignoring the violation, typically your chances go up for finding significant results. So if you don't have homogeneity of variances, it actually makes it a little bit easier to get a significant t-test result. And you're thinking, well, why is that bad? Right? I want that. Yes, you do want your t-test to have a really good chance of being significant, but with the violation, you also have an increased risk of making a type 1 error. So, in other words, when you don't have homogeneity of variance, when you have a violation, that violation, oddly enough, makes it easier typically to get a significant t-test result. But the bad thing is it might be a false positive. You might be celebrating for no good reason. All right, so this is why some reviewers will not accept the t-test is robust argument. They know that the risk of a type 1 error has gone up by using that strategy.